Geotrig lesson 10 day 2. We're going to talk about rational denominators. Overall, we're going to learn how to rationalize denominators, which means not make them look not so nice on the bottom. So to do that, we're going to go over a couple definitions here. The first definition is what's a rational number, then an irrational number, and a complex number. These are all things, again, you talked about way back a couple years ago. The first one is, what is a rational number? I actually have it telling you right there. It's a repeating decimal. It's anything, guys, that can be written as a ratio or a fraction. Terminating decimals are also rational numbers. So, where's my number? Here we go. 0.3 repeat. That's not 0.3 repeat. That's I don't know what that is. 0.3 repeat. 0.3 repeating. That's a repeating decimal. What would we actually use as a fraction for that? Well, you use 0.3333. That's still repeating decimal. What's the fraction? 1/3. We can use 0.25 because 0.25 is the same as 1/4. Those are all what we call rational numbers. Okay? Irrational numbers are basically the opposite of everything that a rational number is. It's non-repeating decimal. It can't be written as a fraction. And it's non-terminating decimal. So when we say non-repeating decimals, it means it's also non-terminating. Pi. If you guys wanted to know, if you want to get it on my iPad, break into my house, you don't have to break in. It's the last 4 digits of pi. So, some of you guys are thinking, huh? I don't get it.
Because it doesn't. I get it.
Okay.
I actually thought about the last 4 digits and I was like, hold up.
So, pi, guys, is 3.14 la-di-da-di-da-di-da-di-da-di-da, right? It never ends. So therefore, it's an irrational number. Square root of 2, square root of 3, square root of 5, square root of 6. Those are all irrational numbers. And then we also have non-real numbers called complex numbers because they involve what letter? I. They have I's in it. Now, I'm going to add something to this. So if you're taking the notes on the computer, you're going to have to type in this one. What is complex standard form? Because we all did this. We already did I. We already talked about all of these things. What is complex standard form? They struggled with this last hour. I's at the back. Okay. Think of the time where we poked I's out by going to the square root dance, right? All of those things. And then we simplified. And I always said, put your answer in complex standard form when appropriate. You guys remember this? What is that form? What's the general form look like? The I's in the back. I agree. That means the complex or the imaginary part goes in the back. What goes in the front?
Oh, the whole number? The square root.
Real numbers?
Yeah.
Sometimes there's a square root, sometimes there's not. Kind of upset people aren't remembering this. A plus B I. You guys remember that now?
Yes.
A plus BI is complex standard form, where A is the real part, B is the complex part. Okay, for the imaginary part. It's important for this lesson and this section to work properly that you understand that the square root of 5 times the square root of 5 is really what? 5. This is square root of 25, which is 5. Because when you square root, or take a square root and you multiply it to another square root, you can take the numbers inside and multiply. So 5, square root of 5 times square root of 5 is the square root of 25, which is 5. We should also remember the square root of -1 is I. We poked the i's out, right? We didn't like negatives inside square roots. We poke it out. And if I end up having an I squared, I can replace all my I squareds with -1. So, the idea, hey, what's the square root of x times square root of x? Square root of x times square root of x, what is that? It's the square root of x squared, which is x. Yes. So it doesn't matter if it's numbers or if it's letters, right? Things cancel each other out. Would you guys agree? Okay. Can I turn the page? So the next slide here is a very wordy explanation of how to simplify or rationalize a denominator. This process, guys, is all about I don't care for square roots when they're in the denominator, in the basement. Denominators up top of fractions, I'm okay with. But once they become in the basement, I don't like it. We kick them out. So I got to fix it. So yes, this is a very wordy, and I'm going to have to explain one of our words in here. So let me read this. To rationalize the denominator, you must multiply the both, the numerator and the denominator by the conjugate of the denominator. So now you're probably thinking, okay, that's a new word for me, right? Conjugate. Okay, watch this, guys. New word. Conjugate. I highlighted.
Really made it hard to see now.
So, what does conjugate or conjugate mean?
The changing of a denominator.
No. It actually is, next sentence, to find a conjugate of something, you change the sign between the two terms. Now, that's hopefully that there are two terms there. This step, I'm realizing, isn't the best of steps because not every time where you have a conjugate and not every time do you have to multiply by it. Or I should say, you can always find one, you're not always going to use it. So this works if there's more than one thing in the denominator. So, let me rephrase number 1. We need to multiply both the top and bottom, because whatever you do to a bottom of a fraction, you must do to the top, okay? So that's obviously needed. You need to multiply the top and bottom by whatever it takes to get rid of the thing you don't like. So, let's think of this. I don't like square root of 2 on the bottom. I can multiply by another number to get rid of the square root. That other number would happen to be just square root of 2. Because square root of 2 times square root of 2 is 2. So that's not multiplying by its conjugate. But if I choose something like this and say, how can I get rid of the square root of 3? Say this is on the bottom. How can I get rid of that square root so there are no square roots left? Someone's like, okay, not a big deal. Just multiply by the thing I don't like, square root of 3, correct? Correct. Don't write this down. Wait. What happens if I take the square root of 3 to the square root of 3? You get negative square root of 9, which is negative 3. Hey, we got rid of it, right? Unfortunately, you would have to also multiply to 2, and then you can't get rid of those. It's 2 times square root of 3. Basically, it's like passing the buck. I don't want this. You take it. Right?
Passing what?
The buck. I don't know. It's a phrase. I don't know. I think money. It's like who's footing the bill, that type of thing, passing the buck.
Who's gonna pass a dollar bill? If you gave me a dollar bill, I'd keep it.
Well,
Yeah, but he'd be the one passing it.
I don't know. Okay. Not sure. Okay. But, do you guys see that by distributing all the way across, I would still have to keep a square root of 3 in this problem? So that is not a good option. Take that away. I don't like it. This is where that conjugate comes in. When there's more than one piece there, I need to multiply by the same numbers, but opposite in the middle. So 2 and square root of 3 still stand. But instead of being minus, you make it a plus. These two terms, these binomials, are what we call conjugates of each other. Okay? Why? Let's take a look. What's 2 times 2? Because now, look at number 2. Step 2 says distribute, or the 4-letter F word, FOIL, both the numerator and the denominator if needed. Okay? So, if 2 times 2 is 4, 2 times square root of 3 is a positive 2 square root of 3. Negative square root of 3 times 2 minus 2 square root of 3. Ooh. And negative square root of 3 times square root of 3 is a minus 3. Do you guys see what's going to happen? The square root of 3's will, and 4 minus 3 is 1. Any more square roots?
Nope.
We got rid of them. But it only got rid of it because that binomial is by multiplying by its conjugate. Okay.
Does that apply anywhere?
What's that?
Does that apply anywhere?
We can use this in other applications as well. Well, if it's an I, we'll get to that on one of our problems as well. So, in number 2, multiply to the top and bottom. Guys, I got a question. Would you guys agree that if I had, let's see, 3 over 7, if I multiply the top by 2, I have to multiply the bottom by 2, so that's 6 over 14, right? Could I take that 1/2? Could I say, I'm going to add 1 to the top and add 1 to the bottom? Because 2/3 is the same thing as 1/2, right? No. So, when working with fractions, the only recourse you have is to multiply or divide to the top and bottom. Remember, multiplying and dividing is the same thing, just multiplying by reciprocals. So, makes it a lot easier. Now, once you have distributed or FOILed to the top and to the bottom, remember, you can multiply numbers outside radicals with numbers outside radicals, and numbers inside radicals with numbers inside radicals. Huh? This is what I mean. So, we're going to take that out of there. What is 2 square root 3 times 3 square root 6?
6 square root.
Actually, don't use 6, just use 7. I don't want to simplify at the end, because you have to simplify that one.
Square root 21.
Do you guys see that I got numbers outside, like 2 and a 3? Well, guess what? It's 2 times the square root of 3 times the square root of 7. Multiplication is commutative. I can put them in any order. So therefore, I can do 2 times 3, which is 6. And square root of 3 times square root of 7 is square root of 21. And then, obviously, take it to the dance, simplify it, right? Now, when I had 3 and 6 there, I could have actually reduced it. 3 and 7 does not make partners, so I cannot leave. That's what it means outside, inside. 3, I combine like terms. If I have 6 square root 21 minus 5 square root 21, what do I have? 1 square root 21. 6 of something minus 5 of something is 1 of something. You simplify your radicals. Take them to square root dances, cube root dances, whatever they are. Take them to the dance. Simplify them. Combine like terms again. Reduce the fraction. So, if by chance you had 6 square root of 21 over 3, it would become what?
3.
2 square root of 21, because I could reduce this to a 2. Okay? You're not going to use every single one of these steps in every problem, but you will have to use the basic idea. Here's our first 2 examples. The first 2 examples are good examples of not using all of those steps. What's the only thing I don't like about this? Number 1. Square root of 2 in the bottom. So how do I get rid of a square root of 2? Multiply it by a square root of 2. But what I do to the bottom, I have to do to the top. Hey, that's pretty cool. What's 5 times square root of 2? 5 square root of 2. I can't do anything about that. What's square root of 2 times square root of 2? 2. Can I reduce it?
No.
Nope, done. Yeah, if you get one of these, you're generally pretty happy. The next one. You should be generally pretty happy about these as well. What don't I like? The square root on the bottom. Thank you. Don't just say square root of 3. Say square root of 3 on the bottom. The square root of 3 on top, I don't care about. Look, I left the square root of 2 up here. I was okay with that, but not down here. So to get rid of a square root of 3 on the bottom, I'm going to let's multiply it to the top and bottom. Hey, wait a minute, guys. We talked about, I had this, I'm going to back up once. We went all the way over here. I had 3 over 7, right? And I multiplied the top by 2 and the bottom by 2, and we said 6 over 14, and that was okay. I multiply the top by 2, I multiply the bottom by 2. You look in there, what's 2 divided by 2? So when you multiply by 1, do you change it? Ever?
No.
No. That's why this works too. I'm multiplying this first one by square root of 2 over square root of 2, which is really 1. I can't multiply something by 1 and expect it to be different. It won't be. It shouldn't be. So when I multiply this one down here by square root of 3 divided by square root of 3, it's multiplying by 1. But look at the bottom. Square root of 3 times square root of 3 is 3. The top, though, has how many pieces of the first fraction? 2. So you better use parentheses and distribute. You're not going to FOIL because it's not a binomial times a binomial. Be careful on that one. So 2 times square root of 3 is 2 square root of 3. Square root of 3 times negative square root of 3 is minus 3. Someone ask. Ask it.
Why?
No. Someone has a question about this because they say, hey, I can simplify that. What do you want to ask?
Can you divide can the 3's cancel?
Can the 3's cancel?
No.
The answer is no. You cannot cancel the 3's because of that sign right there. You're subtracting them. Guys, the only way you can cancel that way is to split them up. Then you can. Or if you're able to factor a 3 completely out of the top. And we can't do that. Questions on that? You guys liking these so far?
Yeah.
Okay, not too bad. 3. Move it to the top.
Yeah, you can't just do that.
You can't just do that.
I think it's fine just as it is.
Change it to a negative square root negative.
Okay. Sawyer is moving on the right track. What is I?
Negative 1.
Square root of negative 1. I think everybody should be under the interpretation that if I leave it as I, it stands for the square root of negative 1. Yes? So why complicate it by switching it to a square root of -1? Instead, I'm not going to multiply the top and bottom by square root of -1. I'm going to multiply the top and bottom by I. 6 times I is I times I is
-1.
I squared, which is actually
-1.
-1. And then we can keep going. Which equals?
6i.
6 divided by -1 is
-6.
-6i. So these aren't too bad, are they? Until you look at number 4. Now you're starting to go, okay.
Easy.
Okay? Number 4 is the first one that we're actually going to have to use the conjugate. It's a binomial divided by a binomial. The only thing I don't care for is the square root of 2 on the bottom. But to get rid of that guy completely, like we did in our example earlier, I have to multiply by what?
3 minus square root of 2.
3 minus square root of 2. But unfortunately, I don't have to just FOIL the bottom, I have to FOIL the top. So it's just more involved, right? It's more work, not necessarily harder work. 5 times 3? 15. 5 times negative square root of 2.
-5 square root of 2.
Negative square root of 2 times 3.
-3 square root of 2.
And negative square root of 2 times negative square root of 2 plus 2. Not too bad, right? We'll leave the simplifying on the next step. The bottom should have some magical stuff going on, right? 3 times 3? 3 times a negative square root of 2. Negative 3 square root of 2. A positive square root of 2 times a positive 3 is a positive 3 square. It's 2. And a positive square root of 2 times a negative square root of 2 is minus 2. Can we clean some stuff up here?
Bottom by 10.
So the top, what can I add together?
15 and 2.
15 and 2 to make.
17.
And what happens to the negative 5 square root of 2 minus 3 square root of 2?
8 square root of 2.
It's minus 8 square root of 2. I have minus 5 of something, and you take another 3 away of them. That means you have a negative 8 of them, and them are square root of 2's. All over.
7.
Hey, look, positive and negative of the same thing. Gone. 9 minus 2, 7. That's a 2. Z's have handlebars, guys. This is a Z.
Yeah, I agree.
It's like Egyptian.
Okay. Makes sense, guys?
It is like Egyptian.
There's more. This one has more I stuff. 5, 1 over 2 plus I. So what should I multiply the top and bottom by?
2 minus
I.
2 minus I. Are you guys starting to see the pattern? 1 times 2 minus I is
2 minus I.
2 minus I. The bottom, though, needs to be FOILed. 2 times 2. 4. 2 times negative I. Minus 2I. I times 2. Plus 2I. And I times negative I.
Negative 1.
Negative I squared. Guys, I don't like to switch that at the same time as I'm saying it. I like to switch it to a negative 1 after. But can I simplify the top at all? No. The bottom 4 can stay. What happens to the 2 i's?
Gone.
Plus or minus gone. And then it becomes minus a
Negative 1.
-1. And when you subtract a -1,
You actually add it.
I'm actually adding. So this becomes 2 minus I all over
4 plus 1.
5.
Why is it minus? Why are there two minuses? Where'd you get one of them from?
The first one comes from the fact that it's minus I squared.
Yep.
And then I squared happens to be
yeah.
-1. And so therefore 2 negatives cancel to make a positive. Guys, 2 minus I all over 5. That's the answer. But it's not simplified. It's got i's. What form should I put this in then?
That other form.
Yeah, that other form, that
Standard I form.
complex standard form. So, that means that I have to divide, right? Separate. So this becomes 2/5 minus 1/5 I. That would be complex standard form. That's the most appropriate method. Now, I didn't get to question 6 with the second group, or the first group, so I'm going to stop here. But I want you guys to quickly grab out your calculators and go back to these problems. Okay, so everybody has their calculators out. Now, guys, to be real honest, this probably isn't the most challenging thing we've done this year, right?
No.
This whole idea of just multiplying by the square root or the conjugate of the bound. But a lot of books, a lot of teachers, a lot of schools, they stopped teaching this. They're like, this is like a lost art because we don't need it anymore. Could you guys physically take a calculator and do 5 divided by square root of 2?
No.
Yes. Do that for me. What do you get when you put in 5 divided by square root of 2?
Decimal.
A decimal. What is it?
A really long decimal.
Give me some, 5 or 6 decimals of it.
3 point, wait, I don't want to say it.
Okay. 3 point what?
Okay, or let me turn.
5. 3.5.
5-3.
5.3. Give or take? Okay. Now, guys, take your calculator and also put this on there. Put 5 times square root of 2, enter, divide that whole thing by 2. Do you get the same results?
No.
You should get the same results.
Should you are.
Okay. It's important, guys. This is why. Most of us in here are like, if I can always look it up, or if I can use my calculator, why do I have to learn it? It's because back in the day, they didn't have calculators. They had big tables of somebody else who sat there and did the long way of things. Now, I think to make sure our answers are correct to what the answer in the back of the book is, you need to know this. But it's okay to take your calculator just to check yourself once in a while. Guys, one last thing. Don't talk right now. Listen, look this way. This, right here, 5 over square root of 2, 5 times square root of 2 over 2, those are what we call exact answers. So, exact. I'm going to say, give me the exact solution. That means you have to rationalize. Simplified, exact answers. This thing is an approximation. It's not the exact answer. So will I accept decimals on the quiz?
Yeah.
No.
No.
Decimals more precise.
No. Square root of 2 is better than 1.414.
And then
Stop.
Like in that 5 over square root of 2 over 2.
There is no homework for tonight. So have a great day.